Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. Today's event is going to be a really interesting one, but before we get started with it, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be able to access it on demand later on. Post-event, we'll be sending out an email that will contain a link to take you to the webinar right on demand. And we are taking questions from the audience. So at any time during the webinar, if you have a question for either of our panelists, please don't wait. Go ahead and use your GoToWebinar control panel and submit your questions. And we will take probably about 10 minutes or so near the end of the presentation and go through the audience questions. Okay, with that, we'll go ahead and get started with today's webinar, which is why open source works for DevOps monitoring. Our panelists today are Chris Chirillo, who is Director of Product Marketing at Influx Data, and David Kaltschmidt, who is Director of User Experience at Grafana Labs. Welcome to you both, Chris and David. How are you today?
Hello, I'm all right.
Great. Well, Chris, I think you're on mute. There you go. Okay. You are. You're the. I know you're going to be driving the conversation, so I'm going to go ahead and mute myself and let you get to it.
Thank you so much, and thanks everybody for joining us today. My name is Chris, and as introduced, I work at Influx Data, and my friend David works at Grafana. The two of us will be going over today's presentation. And if you have any questions, we love to hear what you have to ask us. And essentially what we're going to do is we're going to introduce a couple of really fantastic open source projects to the audience today and describe what they are. In particular, they are InfluxDB and Grafana, and we're going to talk about why you would use them together and go over some basic setup and common configurations. Actually, we'll be going over that in a live demo, so wish us luck. Live demos are always a little bit nerve-wracking. But I have full confidence that David's going to do an amazing job. And then we'll open it up for questions at the end. So basically, the projects that we are talking about are both open source, both extremely popular. The first one is a project called InfluxDB, and it comes from a company called Influx Data. And so some of you might be familiar with it, but not be familiar with the company. So InfluxDB is essentially a time series database, and it's part of a time series platform that is provided by Influx Data. And primarily you use a time series database to be able to store metrics and events data, because metrics and events data essentially has a timestamp and a value associated with it. In parallel, you will probably be using a really nice visualization tool called Grafana, and that is offered by a company called Grafana Labs. And it's a really simple and really powerful tool that allows you to be able to take that time series data that you collect and put it into dashboards that your teams can interact with. And what we've often seen happen is that when people actually provide these kinds of tools in front of people that are not normally data scientists or engineers, some pretty amazing things can happen. Your employees can start to look at the data, start to predict some pretty cool trends, whether they are technical or not, and actually help to make your services or your companies a lot more performant. So let's just talk a little bit about what time series is. And for some of us that have, gone through some programming classes, we might be very familiar with time series. It's a topic that I remember being taught about. But really, very fundamentally, time series is just a set of data that always has a timestamp attached to it. So you have some kind of a measurement, some kind of value that you're trying to track to understand, is it getting better or worse over time? So I'm trying to check the temperature reading of something a minute ago, and I want to compare it to now. And so I need to have 2 points that have a time of a minute ago and now, and then the measurement of the temperature, so I can start to determine if things are going up or down. And so when you plot this data over a graph, of course, one of the axes will always be time. So that's time series data. Now, you can store time series data in whatever you want. At the really basic level, you can use an Excel spreadsheet to store this, but of course you'll quickly run up against a number of limitations, including the amount of data that can get stored, and also performance, and also there's very little that you can do in a spreadsheet. But you can always start with something as basic as that. More often than not, we usually see developers using the closest database that they have on hand. Usually it'll be something like a MySQL, and you can throw that data into there. Which is fine, but what typically happens is that over time, you'll start to notice that there's a lot of work that needs to be put into place in order to make a time series database optimally work for time series data. And so time series databases are optimized for a couple of specific things. They're optimized for collecting data, and that might just seem like obvious. Every database should be able to collect data, but time series data, because we're looking at intervals of time that are pretty small. They can be a minute, they can be a second, a millisecond, nanosecond. All of a sudden, even if you're just collecting just a small number of values, when you start to collect that value against this very precise data, the volume of data that's going to be coming into this database gets to be pretty large. So you want to be able to handle a really high ingest rate for this kind of data. Now, collecting that data isn't the only purpose of looking at time series data. The reason that you want to collect such high volume and highly precise data is that you want to be also look at that data in real time very, very quickly. So that means that querying that data at the same time that you're ingesting that data is going to be important. So you're going to want to make sure that both sides of the coin are very performant. And then the other thing is you want to make sure that since it's large volumes of data, that you're pretty smart with your storage. And so you want to make sure that there's some compaction that can happen with that data, so we don't just overload all the storage that you have. In addition, there's a couple of other capabilities that are tied to time series databases. But at the end of the day, if you compare the characteristics of time series data and what these time series databases are doing, you can quickly see that compared to some traditional databases, any kind of relational database or a search database or a document store database, the features are really optimized for time. And so they're naturally going to be a lot more performant when you're collecting and storing time series database compared to the other databases that you see on the right of this screen. I'm not saying that you can't store time series data in those databases. A lot of people do. A lot of developers actually start, as I mentioned earlier, in a traditional relational database. But you'll quickly see that there's a lot of additional engineering effort that you have to put forth into these solutions. And you might as well just use something that is purpose-built for this particular use case. So then you can spend your engineering efforts more focused on features that are going to make your solution unique. So here are just a couple of customers that we have, customers and users that we have both at Influx Data and also Grafana Labs that are using both a time series database from InfluxDB as well as the Grafana dashboard. And the first use case that we have on the left is a company called New Voice Media. And basically they are a SaaS call center. And the things that they really appreciate about doing this is that they also started with using MySQL in the beginning, but they really needed to make sure that they could really collect very granular data in order to make sure and prove that their service was performant. I think all of us can appreciate that we have very little tolerance for bad calls. And we have even less tolerance when you happen to be on a call for a service that might not be running. Maybe you're on a call to try to get your heating working, or maybe you're on a call to get your test grade. So we're all a little bit anxious when we're on these calls with these call center type solutions. And when those calls get dropped, we're very quick to react and probably put out a bunch of negative tweets to tell the providers how terrible their service is. And this is exactly what was happening with New Voice Media's solution. And they needed to make sure that they could actually get the data a lot faster through their time series database and also via the Grafana dashboard so that they could make sure that they could work with their teams as quickly as possible to resolve things. The second use case that we have here is with another SaaS provider, and they basically are a spend management solution. And they help enterprises to be able to manage all the buying of any kind of materials within an organization. So whether it's the marketing team trying to buy some ads, or it's somebody in manufacturing trying to buy some goods, the spend management solution allows the various departments within an organization to be able to buy and then have all the spend reflected in their budgets. Once again, when you're really, in a critical situation and trying to buy something so you can get it down the line and build that widget that you're trying to build, you don't have the patience to wait for a solution to tell you if these things are on order or if they've been purchased, etc. And so another great situation where Hans has been directed by his management to try to achieve 100% uptime, and they really needed to make sure that they could understand how their entire infrastructure was working, as well as what did the user experience look like. Were people having a hard time with a particular page because it wasn't loading? Were the buttons not responding as quickly? They really need to make sure that they could ensure that the user was making the actual purchase and that the things were going through, and then they get the confirmation as quickly as possible. And they were able to successfully do that with these two open source projects. In fact, when you talk to Hans, what surprised them the most about these two projects is in their initial POC against a number of closed source projects, they originally allocated 3 to 6 weeks for just completing a POC with the various projects. And to their great surprise, they were not only able to create a full functioning POC with Grafana and InfluxDB, they were actually able to make it fully functioning with a number of capabilities, and then just drop the entire POC on all the other projects within that 3-week time frame. And then the third project that I just want to share with everybody is with a company called Houghton Mifflin. And these guys are educational publishers. So if you've ever had any books in school, any hardbound books, traditionally these are the guys that were printing those books. What a lot of people don't know is they actually have a phenomenal ed tech platform with over 1,000 users or engineers that are actually building this platform every day. And it was really important for them that they be able to collect metrics and events that are being generated by all the code that all their engineers are actually building on a day-to-day basis. And so being able to not only put that into a time series database and also into appropriate dashboards, they also needed to make sure that they could also gather the right kind of metrics in their CI/CD pipeline, so they could understand the entire process was working well. So not only did they want to make sure that the platform was performing to their users' expectations, but they wanted to make sure that as they were putting new code into production, that they were ensured that everything was going to be performant before they went into prod. So 3, great use cases of this joint open source projects working together. So very quickly, Influx Data has 4 open source projects. We have Telegraph, which is our collector agents. Majority of them have been created by the community. And so you can collect data from things like databases, applications, various queues, etc. You can use it with InfluxDB or without. You can actually use it with a number of other data sources. And then we have InfluxDB, which is the time series database. That comes with a UI, so you can actually look at the data that's in the database called Chronograph. And then a 4th project called Capacitor, which is basically a processing engine that allows you to then take the data collected to the next level. On the Grafana Lab side, we have this really great dashboarding or visualization tool that's super popular. And you can see below in the 3 boxes the number of GitHub stars that are awarded to each of the projects, and see how popular these things are. So why would you use these 2 projects together? Well, first of all, they're open source, so give it a try, give it a go. In fact, that's how most of the projects get started. People are just kind of curious about what are these 2 open source projects? How might I use it? And you probably would use it, typically when you get started, we see a lot of people just doing a bunch of little projects at home. They've realized, oh, I can probably just measure the temperature of my house or the temperature of my pool. It's a super easy way to get started on a fun weekend project. And then from that, hopefully you'll be inspired to then look at using this for managing your DevOps or including it in your big IoT applications or maybe in some of the real-time analytics projects. So some examples of real-time analytics projects could be, being the collection, storage, and visualization components of high-frequency trading, where you are trying to manage, all the trades that are happening for some stocks on a really, precise time interval. These two are just, as I think I've said a couple of times, I'm a huge fan of Grafana. I think these are two really great projects, and a lot of our joint users really appreciate the combination and have done some pretty miraculous things with them. I can't stress enough, this is open source, which really means that there's a lot of incredible collaborators and contributors to the project. I don't think we would be as popular if we didn't have all these people helping with the writing these two projects, and it's because of the contributions that we get the ability to have such diverse use cases. If we were a traditional closed source application, we'd probably just limit the use case to what we think is best, what our really close users and customers need. But as an open source project, it really is opening it up, widening the use case, and making it a much more robust and interesting solution. So the setup is really easy. You could just go to the website and download all the different components, and you can see how they kind of get connected together in this diagram. So you can use the Telegraph agents to collect any of the metrics from any of the things that I have associated on the left. So system stats, databases, networking, etc. And all the measurements that you collect, the values from whatever you're collecting and the timestamps can then get thrown into InfluxDB. You can also add some tags to give the data some interesting perspective for you. You can put things like where the hosts are located if you're looking at hosts, if you're looking at things like wind turbines, also maybe location, maybe with batteries, what kind of batteries. Maybe you want to make some kind of distinction between a lithium battery and a lead battery. There's a number of things that you can tag your data to, and all of that can be fed into InfluxDB. In addition, you can write into InfluxDB using a number of the client libraries that are available, so you don't have to use the collector agents or Telegraph. And once it's in InfluxDB, you can then process that data. You can set thresholds. You can send it to use some user-defined functions that you've built to actually manipulate the data. A lot of users have their own machine learning frameworks that they throw that data into. And then oftentimes they'll actually bring that trained data back into InfluxDB. And then the cool thing is, not only are they able to then build these fantastic dashboards in Grafana with the data they've collected, but they can also put the predictions in there and be able to look at that data side by side, looking at the historical data that they've collected along with the predictions that they got from their machine learning framework. And then from that, what you can also do is you can set thresholds in Grafana and send out alerts to your team so that they can then make the appropriate changes to whatever systems that you are interested in looking at making sure is performant. So cool thing is it's open source. This isn't a trial. This isn't some kind of 14-day trial. You actually just go and download it and you just use it to your heart's content. And I'd say that both projects have a lot of amazing, huge projects that are just using the open source products. So I recommend that you take a look at it, try it. You'll really see that we really mean it when we say that it's easy to use. In fact, I think one of the things that I might have to warn you is that it can be a little bit addicting once you start pulling in the data and start looking at it and start graphing it. You might end up taking the entire weekend playing around with these projects. To create a database, it's super simple. All you have to do is download InfluxDB. There's a number of different ways you can do it, and I'm not going to go over that. But creating, I'm actually not going to do a live demo of this portion, but it's super easy. You just create a database, name it what you want, and then you can actually see which databases that you have underneath your InfluxDB instance. There's a database called _internal that's used to collect just general statistics about the databases that you're creating. And then when you start using it, what you can do is you can start inserting data really quickly. So this is what we call line protocol, and this is basically the format of the data that you need to insert into InfluxDB. What you have here in this particular instance is CPU is the measurement name, and then we have some tags that we've associated with the data that we're collecting. And then the last point is the value. So that's that measurement that we're collecting. Typically, I would recommend don't use the word value, because as you're trying to build out your dashboards, you're going to be like, what was that again? Try to be a little bit more specific. In fact, I should have done that in my own example. But you'll notice that there's no timestamp here, so you can either insert a timestamp, and I recommend doing that because you want to collect the timestamp from the thing that you're measuring. And so that might be a few seconds delay if you're going to rely on InfluxDB to insert a timestamp. But either will do, and there are use cases for both scenarios. And then you can just start to query the data. So you can just look at everything that you have in there, but you can see in the little picture below, I have a really nice simple table, and you can imagine that I could actually query on things like just the location. So I can group things by just London, and I would see that in this particular instance that I only have one metric that's being collected. But hopefully you can start to see the power, and I'm sure when we go through David's demo, you'll see even more powerful things that can be done with the combination. So with that, I'm going to now switch over to David.
Hey everyone. So
and there you go.
Yep. All right, welcome everyone. So what you see here is the Grafana login page. You'll get to this if you install Grafana on your local system, and then you just use the URL that's up here, localhost 3000, and then you will be redirected to the login page. And this is also how you can tell that Grafana has been installed correctly. If you don't see the page under this URL, something went wrong there. Anyway, we see this now. So, and with every default install, we get the user admin and the password admin. So we're going to try and log in. And yeah, this worked. So now it's suggesting, okay, well, admin isn't particularly secure, so we should probably change our password. But for the purpose of this demo, I'm going to skip this now. And then I'll end up in the Grafana home screen, which tells me how far I am in the process of becoming a happy Grafana user. So I've already installed Grafana. This is crossed out on the far left. And then my next step would be to add a data source. And I've also been following what Chris was just showing, and I've added a MyDB influx database. And so we're going to try and add that now too. So I'm just going to choose the influx database data source. And the URL is also, it's also running on my machine. It's running on this port, 8086. And it's going to be the default database. That's fine, the default data source. And it was MyDB. And I don't need any authentication because it's just running on my machine. And let's save this for now. Okay, so saving also did a little connection test. And by seeing this little green check mark here, it means that everything worked fine. So now I can go back to the main dashboard and just go home. So now I've created my first data source, so that's good. So the next step is I want to see some data, and for that I need to create a little dashboard. And here, let's not start with the graph panel right away, but let's start with a table first, because I just want to show quickly on how we can have a look at the raw data that was also being stored. So let me quickly name this panel influx data raw, for example. And I'm going to choose our influx database that I created earlier. And now I can look at the CPU measurements that were just being added. But by default, it's already assuming a couple of things here, basically that there are certain fields. But to just look at raw data, let's just get all the fields. Let's remove some group bys here. So just really quickly, So this allows me now to see what's actually being stored in the influx DB MyDB data source database, and under the measurement, which is sort of like a table, CPU. So this is how I can see the raw data. And you should also be able to see this if you follow the steps that were shown earlier. So this is not particularly interesting, but let's perhaps look at a way to graph this, because we have already a couple of data points, right? They've been added in a 1 second distance, so that's fine. And there's different values here. So I'm going to just add a graph panel, and I'm going to use the same data source here, and I'm going to use the CPU. And here it's already a bit difficult to tell that something's being drawn, right? I do see a legend, right? So this is okay. The field value is correct, right? It was alluded to that name is not really, doesn't tell you much, but at least it exists, so that's good. And I see a value there, so that's also good. There are occasions where I don't see them. For example, if I change the time interval to something bigger, oh no, I can still see it. Okay. If you don't see any data there, I mean, we only have these little data points there, then you might have to change these settings here, fill to none, but by default it's null. And so what already is happening here is that we're already applying a couple of functions to the time series result. And what we're basically saying is we're grouping the return values by time and over a certain time period, which here is the interval, which is being calculated dynamically depending on what I choose in the time selector. Here is the range. So for example, 6 hours is going to give me little time windows of probably, I'm guessing 10 seconds or something like this, because that is what makes sense to see here visually, right? It wouldn't make sense to have any other, or to have more fine-grained time interval. For example, if I choose 1 second, it doesn't really tell me more. Conversely, if I choose a really big window here, I should also stop seeing things here. What also helps is if I change the style a bit. So for example, if I go to display and then say, give me points, I can get to see exactly the data points that I entered. Okay, so this isn't all very exciting with this test data that we had. So I already went ahead and installed Telegraph, which was also presented on another slide. And Telegraph comes with a couple of default plugins, one of which is CPU, and the other one is disk and memory, and it monitors your local system. And so let's go ahead and add a second data source. So let's change this real quick. Let's save this. Okay. And we're going to add another data source here, influx. This time I'm going to call it Telegraph. It'll be under the same URL because it's in the same influx DB instance, but the database is going to be called Telegraph. That is going to be automatically created when you point your Telegraph to your local influx DB. So let's see if that worked. Yeah, that worked. So now I can go back to my dashboard, and in here I can then choose a different data source, Telegraph. Okay, and now I'm choosing, the default. I'm choosing the CPU measurements here, and then I select the field, and here it already suggests me other values than value, right? So the interesting ones would be, for example, usage system, which would tell me the CPU usage of system processes, for example. And here we already see the effect of the group by on the time. For example, here it's calculating the mean, so that's the It's the average over that time interval. And if I choose so then $__interval would be the automatically calculated time interval. And if I want a bit more influence here, I can choose a longer one, and then I get more, and then I get everything a bit more smooth. Okay, apologies. All right, so, and another interesting thing here is that if we add the same, just reset this. If we add the same query, basically, then we can also apply a different function. Let me just also choose CPU, and we want usage system. And then instead of mean, I'm going to remove this, but I'm going to add a transformation, for example, moving average. And then I should be able to compare these two values. So, So this should show something. But it's not. Okay. All right. Live demo. Great. All right. Let's move on to the next point. We've got plenty of options here. Or let me just quickly say what I wanted to show. I wanted to be able to plot both, but I wanted to show that one had. I wanted to compare the average versus a moving average, right? So, and the moving average is something that you can smooth a bit, and I'm not really sure why this isn't working right now. Just one final try here. It's I should get 2 series back, but I don't. Okay. Nothing to worry about. We still have a couple of options in the for the display to show. For that, let me just quickly change the metrics again here to add a second field. So we have usage user, for example. So this already shows 2 different ones, right? This is something where I guess we could highlight this. We could highlight how 2 different transformations can be applied. Or not. I guess I'm using moving average wrong. Okay. Okay. All right, this worked. So yeah. So the rest of Grafana, the rest of the Grafana tabs here, they give you a couple of options on how to format these graphs. You can format the axis. You can format the legends. Another interesting thing here is if you have, for example, now I have CPU usage for users and also for the system. There, for example, it makes sense to stack them, right? So if I activate stacking here, they get thrown on top of each other because, in effect, you only have one CPU and it's a shared, or for this particular purpose here, and that resource is being shared. So if all the usage gets added up and it's fully used, you should end up at 100%. Okay, so we've added a data source telegraph. We've compared the moving average to the mean. We showed the stacked option, and now let's move on to template variables. So this is an interesting feature of Grafana, which allows you to parameterize your metrics queries. So here, for example, we only had CPU. The CPU was it was a total CPU, and there are ways to get to more fine-grained data. Just quickly check. Oh, no, it doesn't. Okay. Okay, let's quickly check. And the feature variables is associated with a dashboard, and you would add a variable by, for example, you would add a variable called dashboard, no, data center, for example, data center, and it can be a query, but perhaps we do custom values here. So it would be DC1, DC2, and DC3. And here we get a preview of values, right? So this can also be populated dynamically based on a query, but we don't have this right now. And so now I click add, and now this variable data center is associated with this dashboard. So now I can use it in the queries. So I can go back to the dashboard, and in here, I can, for example, use, first of all, it appears up here, right? So, and it's currently set to DC1. And I can use it either in the queries but also in the alias. So if I use it here, so and then it appears here, and I can also use it in these field values here, for example. So here, this would work as well. And currently that particular field won't return anything because there's no measurement called DC, or no field called DC1. But what I would quite like to do is I quite like to check the query inspector to see how would I click together here gets translated to a query, right? And for example, here it would start using, or it would use the DC1 field in this area here. Okay. And let's go back. This is a nice, this query inspector is very nice also to debug other issues. For example, if you don't really see, if something else is going wrong. Here's for example, a hint that I should have checked earlier to help me with the moving average. So it looks like an aggregate function is required inside the call to moving average. Okay. So I can go back, close this, and just close this one. And so we need a mean, okay. And now this should have worked. Yeah, here. So I'm still doing the query with the moving average here, and it's using the mean inside. And I also get results back. And this also helps me debug what Influx sends back. So it's sending CPU results with these columns, and it's sending these values, right? So whenever something goes wrong and I don't see what I want to see, I go to the query inspector. So this helps. So All right, so the last thing I can show is a dashboard can not only have template variables, but also annotations involved. And annotations are something that helps you with events that occur during your operations shift, or for example, you roll out a new version, or the weather changes, or something else. And what I did was I was tracking the attendees while the first couple of slides were being presented. So I tracked them in the MyDB. And the query for this was, this is just an influx query. And webinar. And I was tracking which webinar it is and the slides. So, and then I can have that as a text here, as a tag as well. So here. So let's see if that worked. So now this was when the webinar started at 4 o'clock my time. And then here are a couple of events, right? And these were always when the slides were being changed. So this was slide 14 and 88 attendees. Okay. All right. So this is just an example on what you can do, or how you can hook up a log aggregation system or something that has events on just a different time scale, and then overlay them on the time series that you're plotting here. So the last couple of minutes, I'm going to show you some overrides. So for example, if you want to change the way something is displayed, right? So I can change this in the series overrides. So for example, if the orange line, if I want to somehow have that differently, I can find this here. Oh, yeah, or not. Guessing it's all right. Since they're all the same, I can start using something else here, which is, well, first of all, I can start removing things that I don't need anymore. Yeah, so now I only have those. Otherwise, I could have used an alias here that would have aliased this particular time series to a certain name. So, and now I can go back to display, and now I'm addressing just this only one. And here I can say I want I also want bars. Okay, that didn't work. Okay, I guess because we lost a bit of data here. Usage system. Oh yeah, here we go. So that's a bit better. And usage guest. Let's remove this query so that we make it all clear. Okay. Okay, all right. So now I've modified the behavior or the way a single series is being plotted here. Yeah, as I said earlier, this is particularly helpful when you plot multiple series. So the last couple of minutes, we have a couple of other panel types, which are, for example, the single stat. Here you can basically show one single number from a measurement, and I'm going back to logs that where I basically track the number of attendees. So let me just rename this here, attendees, and then I don't want any of the grouping, basically. I really only want the last value here. And here I need to be careful, because here the query can already do aggregation, like I just deactivated, but the options here can do the same, right? So here it's already averaging over what's being returned by the time series, but I just want the last one, which was 89. Okay, and then I can add thresholds to give this whole thing a bit more oomph. And so, for example, if I do this, so now because 98 is above 80, 89 is above 80, that means it's being colored red. So if I change the thresholds here to 100, it goes back to being colored orange. Yep. All right. So we have about 15 minutes left, and I think I hand back to Chris. All right.
Okay, cool. Sorry about that. So let's now just kind of go through, these items. So yeah, so going through the demo, you saw David added InfluxDB as a data source, and he shared with you how you can create these various panels in your dashboard. We took a look at actually a couple of different options with the panels. We graphed some of the data, changed the query, and also we looked at using Telegraph as a data source as well, and was able to see the stacked bar charts. I thought we also looked at the template variables with the DC1, the various data centers, and also you can also annotate, which is really critical when you think about these dashboards, because we often can forget. David, do you want to just go over some of these configuration enhancements or performance ideas that we have to just share with the audience?
Yeah, so it's always good to definitely limit your queries. For example, if you do a select star on something, you should definitely put a limit on them to return only a fixed number of rows. Then and that's also important for the single stat, right? Because you don't need a really long time series to give you the latest value, for example. And similarly, the annotations, you should also be careful there. And in general, we recommend having returning not too many time series to be plotted, because currently the browser is getting a bit slower when it needs to render a lot of legend items, and we're working on addressing this. So if you have a lot of, or if you do have to run a lot of graphs and the legend items aren't that important, we recommend not showing them, actually. You can still hover over the graph and see them and see the value of your selector, but at least they won't be rendered constantly. Yeah, I think the last item there is important too. If you have a lot of tags, the query builder dropdowns will also be a bit slow, but we're also working on addressing that.
But David, don't you think, even just from a UX perspective, besides trying to deal with making sure that your dashboards are performance, you always want to consider what your user is looking at. And it's really easy to get carried away the first time you use Grafana, because you just want to use every single panel type that's available. I know I did. But consider what your users are trying to understand with the data. Really try to make sure that you're only presenting stuff that's useful to them, and then you'll naturally start to abide by these recommendations.
Mm-hmm. Yeah, no, I agree. Yeah.
Do you want to run through these two as well, David?
Yeah. So Yeah, so every query gets reevaluated, which is basically also due to how the date is being calculated. So every request normally has a relative date, which would be as you've seen in a time picker, it would be something like last 6 hours. So that needs to be reinterpreted every time it hits the backend, every time it hits the database. And so if you click on the refresh button a lot of the times, the query now is being sent, right? And now is then reinterpreted each time and then returns a different time series, right? Or a different period of the time series. And then you also have the option to downsample data for better performance and and use retention policies, but I'm a bit less familiar with those.
Yeah, and I think overall these configuration recommendations are actually good for whether you use Grafana or not. And another use case that we didn't really touch on is that there are a number of users that might build an app. Maybe it's a smartphone app, and maybe because they're trying to present some kind of graph to their consumers of some kind of wearable, for example. You're going to have the same kind of performance issues with that kind of a dashboard, or with a Grafana dashboard. So just think about the data that you have. Remember, we're ingesting high amounts of data over time. One thing that we didn't really touch upon is that with InfluxDB, you can actually downsample the data if you need to, which we recommend actually for a lot of people, because what's interesting about time series is over time, the precision of the data is not as important. It's more the shape of the data that you want to be able to keep for historical purposes. And then you can also set various retention policies, and you can actually set retention policies not just like overall for the solution, but you can actually make it a lot more fine-grained depending on what data that you're collecting. And then in summary, and I'll just leave this off, David, and you just chime in. We both think that these are really great solutions. Hopefully you are inspired by the demo, and you can see what I mean by when I say that it's really addicting once you start pulling in data and start looking at it and start realizing that, wow, I can really learn a lot from what I'm collecting, and there's probably a lot of things that we can do with it. Right? We recommend very strongly. They're both open source. Download it, try it, play with it. And you can definitely learn more from both of the communities. In fact, the communities intersect quite a bit. So when you start learning more, you'll start to see that there's a lot of users that are using both quite extensively. And we have a couple of really amazing events that are coming up. GrafanaCon is coming in Los Angeles, and we're huge participants. And Grafana has graciously included a discount code here for everybody that's attending today's webinar. And then we just finished Influx Days, the user conference in San Francisco last week, but we are marching towards the next one in New York City. And the great thing about both of these events is that you will feel the real collaborative nature of open source. It's all about users. It's about users sharing their experiences. They'll actually show the dashboards that they created, the queries that they've created. Sometimes they'll even share the challenges that they have with one or both projects. And it's all about transparency, and it's all about making these solutions even better. And also, it's a great way to be able to contribute to both projects. So, David, do you have some final words as well?
I was at last GrafanaCon in March, which was a blast. It was in Amsterdam, and yeah, I can highly recommend coming there. You'll see people presenting how they use Grafana in various different ways. Some are running their hydro power plants with it, but that's a whole other story. But Los Angeles is probably going to be fun too.
Excellent. So it looks like we have some questions. So should we go through the list, David?
Sure.
Excellent. All right, looks like we got a question from Zelko. So how would something like Prometheus play with InfluxDB and Grafana? I can start that one first, and then David, why don't you chime in? So I think there's two answers to this. I think the first answer is what I typically see with users is that they're going to use the tool that's specifically built for what it's trying to accomplish. And so a lot of times I'll see in customers or users' environments that they use all three projects. They'll use Prometheus for something very specific and InfluxDB for something specific. So they'll use them separately, but we'll have all three in the environment, and then typically use Grafana dashboard to be able to pull data from both sources. The second use case that we see is that sometimes you want to keep the data that you collect with Prometheus around for a lot longer. So Prometheus has graciously built a set of APIs so that we can actually be the long-term store for the data collected in Prometheus. So those are the two typical use cases that I see. David, do you see any other use cases between the three?
No, I think that's it. I think if you like to use Prometheus and benefit of its service discovery, for example, you would definitely use it, and then either just use Grafana or you can use InfluxDB as long-term storage for it. Yeah, so the three would play really nicely together.
Let's see, the next question from Alexandra is, would you be able to post a recorded version? Yeah, that's definitely going to be possible. You will be getting, I think it was described at the beginning of the webcast that you should be getting a notification of when that's available. So you can look at it as many times as you'd like, Alexandra, and share it with all your friends. And then Mike asked, there was a hint that Tick will go into a single tool with InfluxDB 2.0. Yes and no. So Telegraph will still remain Telegraph. I mean, those are collector agents that work not only with InfluxDB, but a number of other data sources. So that will remain as is. It's probably the most popular project. And then as far as Capacitor and InfluxQL, InfluxDB, those are the things that really are going to become elevated with InfluxDB 2.0. And we just posted Paul Dix's presentation from Influx Days in our YouTube channel, so you could take a look at it. The other thing that's really great is Matt from Grafana was also there, and he presented the Flux Builder that's in Grafana. So both of those presentations are there, and you can take a look at it. We also have a set of office hours that are scheduled. So if you want to come and talk directly with our engineers, and hopefully we'll also get some of the Grafana engineers on the office channel as well. You'll be able to talk directly with the team and hear about what they've been doing and play around with it and share your experiences. So that's all I see for questions so far. But we're almost at the top of the hour. David, any kind of last words of advice for everybody on our webinar today?
I guess the biggest thing I want to add is that the moving average also needs an aggregator function, which I've figured out now by looking at the error codes. So Query Inspector is your friend whenever you need to help yourself with Grafana and Influx. I think that's my biggest takeaway.
All right, great. Well, Chris, thanks for doing the questions for me. I appreciate that. So yeah, I do want to thank the audience, everybody in the audience who did submit a question. Thanks so much for doing that. I also want to remind the audience, as Chris did earlier, that today's event has been recorded. So if you missed any or all of it, you can always go and listen to it on demand. Or if you just want to listen to it again, you'll be able to do so on demand. We're going to be sending out a link later on this afternoon in an email that will take you directly to the webinar. The webinar is also going to be living on the DevOps.com website. So if you're on the site, go ahead and click on the webinar section on demand. It should be right there waiting for you. And as always, while you're there, go ahead and check out the other webinars that we have, both upcoming and on demand. Hopefully there will be one or two at least that pique your interest. Chris and David, thank you both so much for giving such a great presentation. I appreciate it. I'm sure the audience does as well.
Thank you. We had fun.
All right, great. Well, and also thank you to the audience for joining us today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.
Bye-bye.